Okay, so today we're going to go over radians and the unit circle. Okay, so first of all, what is a radian? The best way to describe a radian is like it helps you measure angles, except for it doesn't have a unit, which sounds really confusing, right? Because you're like, it doesn't have a unit, Miss Johnson? No, it doesn't have a unit. So the things that we do know is that radians are measured like, um, actually, I'm just going to start like this. So the way I want you to think about radians goes like this. So this is your XY plane, except for now I'm going to call it a unit circle, okay, or a circle. So I want you to imagine that instead of me labeling this with X comma Y, I'm now like measuring it with angles. And the way I want you to like pretend is that there's a book. Oops. There's a book that's sitting right here. Do you guys all see my closed book right there? Yeah. Okay. Does everybody see my closed book sitting on the table? Everybody see that? Good. Now, when I open the book, do you see how it looks like it's a bunch of angles opening up very, very slowly? So, can you imagine like here it's opening up, and they're always going to be vertexed at the center. They're always going to be vertexed at the 0, 0. Does everybody see that? So I can open the book up and I can lay it flat on the table. Does everybody see my book open up flat on the table? But this is like a really cool table because I can actually open that book up even more all the way around. And then you kind of see my circle, right? It's a pretty horrible drawing, but does everybody see what I'm saying? Okay, good. So the first thing that I want to teach you, and that goes away, is that pi is radians. You remember pi from 7th grade being 3.14, and that's also in radians. That's why we didn't have to write radians because radians is not really doesn't have a unit. Okay. This is also true, but I also want you to remember that pi, this is the new thing, equals to 180 degrees. Okay. So what does that mean, Miss Johnson? It means that, like, back to my book. When the book is closed sitting on the table, I want you to remember that's 0 degrees. Is everybody okay with that? Now, as I open the book up and I open it and it's opened up completely and it's flat. Everybody see completely and it's opened up flat? That's this guy over here. Does everybody see him? He's opened up flat. Okay. That's pi. Or you guys would call him 180. Okay. So since I want to make sure that you guys are following me, I want to label these axes according to degrees. So follow me. Now, this is the part that I lose people because you're not, I need you to pay attention to this. And I showed you earlier, and the reason why I showed you was because if you can get this plus your 30, 60, 90 and your 45, 45, 90 triangle, it's like when a third grader gets multiplication tables and think about how they're setting themselves up for their best for fifth, sixth, and seventh, eighth, ninth, 10th, 11th, 12th grade. Does that make sense? Does everybody remember how important multiplication tables were when you were in sixth grade? Like, Miss Johnson, I could have used a calculator. I'm going to tell you right now, I can show you how to use a calculator on this. But when you use a calculator on this, all the stuff that I showed you for integrated 3 and my senior class you'll be lost. So what I want you to do, very good. You already answered it. I want you to tell me what this angle would be when the book is open to that, and then when the book is opened all the way here. Okay. So while you do that, I'm going to talk. So 0 is our starting place. Okay. So whenever we're talking about a number line, we always reference 0 because 0 is like kind of like your starting point. So just like that, when we're talking about angles on the unit circle, we're always going to start with our book closed. And then we're going to open it to however much we want to open it. Okay. All right. So I think some of you already have it. So very good. Let me give you people some points. Yes, very good. Go ahead and put your answers in the chat if you are feeling kind of like that. Oh, that's interesting. So someone already brought up the idea of negative. Okay. And I will say the way I've been opening up the book has always been 90. I mean, positive. Sorry, I said the answer. Has always been positive. So if you think about what negative is, if opening up the book is in this direction and this is considered positive, what would negative be? What would negative be? If opening up the book this way, and we call this counterclockwise. Do you guys understand the word counterclockwise? Have you ever heard this term? It might be a dead term. You'd have to know what a clock is first. And I don't know if you guys have seen a clock. So when you have a clock, say it's 3 o'clock. It's not 3 o'clock right now. Maybe you wish it was, but it's not. When the hands go around, they go in this direction. We call this direction clockwise. Okay, it's the way the clock goes. Very good. So counter means opposite, against, instead of. Does that make sense? Very good. So clockwise, yeah, you did use it a lot in 8th grade because you guys were rotating things. That's right. So counterclockwise is the positive way to go for angles. Does that make sense? So counter means against, opposite, whatever. So if we're going this way, this would be considered a negative going clockwise, right? All right. Okay, moving on. So you guys all labeled this very well. This was 90 degrees up here. I should put it at the top. I don't like where I put that. Sorry. This is 90 degrees here, and this is 270 degrees here. Lots of different ways for you to figure this out. I'll explain a couple. The reason why this is 90 degrees is because it looks like a 90-degree angle, doesn't it? Yay, that's exactly right. Another reason why you guys figured this out is because if this is 180 and this is half of it, so then that means this is 90 degrees. Half of 180 is 90. You could have also figured out and said, well, what plus what gives me 180? Oh, that's 90 plus 90. That gives me 180. Everybody okay so far? And then the same thing goes for 270. So you would have said 390s makes 270. You could have said 180 plus 90 is 270. And then last but not least, I can go in a full circle, and then this would be 360 degrees. Okay. So far, so good? Okay. Now, that is in terms of degrees. Just like if you speak more than one language, angles could be measured in more than one kind of way. So here we wrote the answers in degrees. I need you to write the answers in terms of pi. So do the same math that you just did. And if you said that over here, this is pi, what would that make up here? So go ahead and fill that out. And the way you can write it in Desmos, when you want to write pi, there's the pi symbol, but you can also just put pi and it'll make the symbol. So you can put pi. Yeah, very good. So very good. Thank you for putting your answer in. Good job. Very good. And pi is spelled P-I, not P-I-E. P-I-E is really yummy. P-I is the number. Very good. Keep going. All right. Anybody else? What would we put up here? So I don't like, I'm just going to tell you right now, someone put 1.57. Yes, but no. Right? I'm just going to tell you my preference is never to use decimals ever. Ever. So I'm going to take pi and I'm going to divide them by 2. And then my answer is pi over 2. Someone wrote half of pi, which is okay. Pi over 2 is a little bit less to write. Mathematicians are always going to write things that are less to write because it's more efficient. So that's pi over 2. Now, if we were in class together, I would make you, no, you're not writing anything in Desmos. I would make you choral count with me. Do you guys remember choral counting in like 2nd grade? Guys, we're going to choral count or skip count our numbers. We're going to choral count our 5s. Ready? Go. 5, 10, 15, 20. And you would all be saying this together, correct? So we're going to choral count by counting pi over 2s. and I am going to write them around my circle. This is one of the most important parts that people neglect. I've taught this for years, and when you don't choral count, you won't get the next parts that I really want you to get. If you get the next parts, I'm going to tell you, you're setting yourself up for like really easy understanding next year. All right. So I'm going to count by pi over 2s, and I'm going to jump to the next axis. Okay. So here we are at pi over 2. Here we are at pi over 2. Everybody see me? And then we're going to go here. So this is 1 pi over 2. This would be 2 pi over 2. Everybody follow me? Okay, count with me. Pi over 2, 2 pi over 2. What would come next? 3 pi over 2. Very good. Thank you. You guys all see 3 pi over 2? We're just counting by pi's. It's like 1 orange, 2 oranges, 3 oranges, 4 oranges. Yeah, so I'm going to write 4 pi over 2. And then you can continue, but we usually talk about the very first circle first, and that's it. Okay. So with that being said, you now know how to count. And this is what I'm going to keep doing this over and over again today. Any questions on this? Now, some of you are like, Miss Johnson, but 2 pi over 2 simplifies, right? And it's just pi. Yes. Yes. I understand that. But I want you to learn how to choral count with me. Okay. Miss Johnson, instead of writing 4 pi over 2, can I simplify that? Yes. In fact, do that now. Simplify 4 pi over 2 right now. Yeah. Okay. Someone asks a really good question. Hey, Miss Johnson, did you mean that there's more than this circle? Yeah. So can you imagine? Okay. Now I'm going to go away from my book, and now I'm going to sit you in a spinny chair. Everybody sitting in a spinny chair? Good. Sitting in a spinny chair. In front of you, like, have you ever heard someone say something like, at your 12 o'clock, at your 12 o'clock, they're at your 9 o'clock? Does everybody know that reference? Okay. So it's almost like you're sitting on a clock. Everybody look down, look at the clock. Everybody look down, look at the clock. Good. In front of you is 12 o'clock. So when they say things like, dude, he's at your 12 o'clock, he's saying, dude, he's right in front of you. Everybody okay with that? 12 o'clock. Then where would your 6 o'clock be? If I said, hey, where's your 6 o'clock? Where's that? Yeah, it's directly behind you. And if I said, like, your 3 o'clock, right? That would be directly to your right. Now, why, Miss Johnson, why wouldn't they just say to your right? Because if I'm facing you, my right is your left and your left is my right. And I say to your right, and I'm like, wait, my right, your right. Wait, my right? Like confusing language. Do you guys all see that? So, but if I say to your 3 o'clock, everybody knows I'm talking about your directly to the right. That makes sense? Okay. Everyone's in your spinning chair. Okay. So let's say that I do this thing where I say, okay, I need you to spin in a circle. And you're like, how many circles, Miss Johnson? I'm like, I don't care. I'm going to shut my eyes, but I need you to be facing your 3 o'clock when I open my eyes. So correct me if I'm wrong. If you're sitting here in your spinny chair facing this way, now you can do this much, right? You can spin that much. Is that the only way that you can spin in that spinny chair? No. What else could you do? Oh, you can go clockwise, but let's pretend we're still going counterclockwise because we want to keep that positive in your head. But very good option. What's another way you can go? I think you're thinking about this too hard. You're a little human. You're like in second grade. What do they love doing in chairs? Yes, thank you for demonstrating, sir. Okay, I was referring to spinning fast. Okay. Would they only spin one time like this? No, they'd go in a bunch of circles. So when I say that there's more circles, I mean that you could literally go like this, like this, like this, like this. And as long as you land here, you're good. So how many circles was that? I don't know. I actually don't care. But for our purposes today, we're only going to be talking about our very first circle. Does that make sense? One rotation. Is that okay? But just know that I can keep choral counting with you: pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6. Do you see how I can keep going in a circle? Everybody okay with that? But we're only going to talk about our first circle. Any questions on this very first one? A lot of you got this answer correctly. Thank you for participating. It is 2 pi. So this is the standard kind of thing that I'm going to build everything off of. If you've paid attention, I'm going to add one more thing to this, and then we're going to really build this thing out. In fact, we're going to build this thing out so much that you won't need this. This is called the unit circle. This gives a lot of really good information, except for in my findings as a teacher, when students depend on this so much, it's like when like students depended on the multiplication table too much instead of understanding it. Does that make sense? So, hey, what's 3 times 4? And you're like, 3, 4, boop, 12. But if you don't know 3 times 4 and you're like, okay, 3 times 4 is 12. 3, 6, 9, 12. 12, Miss Johnson, right? When you depend on this too much, it won't give you the understanding that you need, and the things that come after it will be difficult. Okay. Right. So the next thing that I want to teach you is your 30, 60, 90, and your 45, 45, 90, which we've already done, but I kind of want to make sure that we understand it. All right. I do make noise while I draw. It's kind of fun. Okay, so you guys remember this from a couple of lessons ago. We went over our 45, 45, 90 triangle and our 30, 60, 90 triangle. These should look very familiar. So I go back and forth between labeling my triangles like this and then labeling my triangles like this. X, 2x, x root 3. Or x, x, x root 2. I will use both of them depending on which one makes the more sense. But again, between this 30, 60, 90, and the 45, 45, 90, and the radians, if you know these two things, um, I can I can get you through all of integrated 3 pre-calculus calculus without a problem. And you will actually excel in those. You won't like it won't be hard at all. But these are my building blocks. Okay. So let's go back to our pi. Since pi is 180, instead of writing 60, how would I write that, Miss Johnson? How would I write that in terms of pi? So then that means you want to convert. So 60 degrees times what equals to pi? I need to write this in terms of pi, and I'll put it like that. Doesn't that look like a face? That looks like a face with mad eyebrows or something. All right, anyways. So the way I'm going to convert this is by multiplying by a factor of pi over 180 or 180 over pi. Because degrees is on the top, I want degrees on the bottom so that it cancels. And this is, in case you don't recognize, this is just the number 1. Okay, it's the number 1 because pi is the same as 180. Okay, they're just different units. All right, so then you simplify and then you're done. So 60 and 180 have a common factor of what? What does 60 and 180 have a common factor of? Yeah, there's definitely a 2. Good. Is there a bigger number that you could take out of both 60 and 180? 30 is good. Let's do 30. So how many 30s in 60? 2. How many 30s in 180? 6. And then I ask again, do 2 and 6 have a common factor? And you guys are like, yeah, 2. Good. How many 2's in 2? You say 1. How many 2's in 6? 3. Pi over 3. So here's another thing I'd like you to memorize is that pi over 3 equals to 60 degrees. So really, I can squeeze him in here and call him the pi over 3 triangle, right? Similarly, I would want you to do that with 30 degrees. So here is where you're going to practice. You're going to convert 30 degrees. And then over here, you're going to convert 45 degrees. I need I need you to translate from degrees to radians. So go ahead and do that. And then we'll be right back when you're done with your answer. All right. So you guys converted it and you would have gotten, let's see, you would have done pi over 180. And you would have said, oh, they both have 30s. And I would have said, exactly. So that's 1 and that's 6. So this is pi over 6. So these denominators to me are so important. Whenever I see a 3, a 6, or whatever you get for the 45, I instantly know I'm in my 30, 60, 90 or my 45, 45, 90. So keep that in mind, okay? And then over here we have 45 times pi over 180. Some of you did 45. Some of you did 5s. I don't know what you did. Some of you did 9s. I think I'll do 9. So this is 5 9s and 29s. And you're like, oh, that's 1 and that's 4. So whenever I see any of these denominators, same with me, 3, 6, 4, I know that I'm in these two triangles. Okay. All right. Now I'm going to take this and do this with it. Okay. I'm going to put it on my axes. All right, here we go. So I'm going to do pi over 6, pi over 3 first. Actually, I'll do pi over 4 first because that makes more sense. Okay. So here we already have 0. I'm going to talk to you guys in terms of pi right now, okay? Pi over 2, because that's what I'm focusing on. I'm assuming that your next year's teacher will go over degrees. I just really want to make sure that you're comfortable with this. So here's that. So then, now what I want to do is I want to put this triangle. Can you imagine me picking him up? So everybody pick up that triangle, like rotate him a little bit, and then have this angle open up here 45 degrees. Have the book open 45 degrees, right? Do you guys all see my line here? Everybody good? So here's the triangle for it. This is what I usually say. I say draw the angle, draw the triangle, right? And when you draw the triangle, you're always taking the elevator to the x-axis. You're either going to go down or you're going to go up. You're never going to go left and right because the elevators don't go left and right unless you're in Charlie and the Chocolate Factory. But we're not talking about that. So I am going to draw all of these angles in. So do you guys all see my triangle here? Oops, I can't draw. And my triangle here. Does everybody see my triangle? Everybody see this triangle here? It kind of looks like a bow tie. Does everybody see that? Not perfect. Okay, not perfect at all, but that's pretty good. So what I'm going to do is I'm going to erase my triangle parts and I just kind of want to look at the actual angles. So I'm going to be looking right here. Now, please pretend that I did a really fantastic job of drawing like perpendicular axes and that's actually 45 degrees because then it would look so much better. Okay, so now everybody, you are going to count with me, but we're going to choral count by counting pi over 4. So here's our first one, pi over 4. Everybody good? Say the next one. 2 pi over 4. Then it's 3 pi over 4. And then it's pi. This is where I pause. When I think about this pi, I think about pi in two different ways. The first way I think about pi is I think about like actual pie, like strawberry pie, lemon pie, whatever. And then apple pie, exactly. And then we cut up the pie. In this case, we've cut up the pie into 4 slices. Does everybody see my 4 slices? Right? Slice 1 for you, for me, for her. I don't know, making it up. Does everybody see that? Now, The reason why I have you think like this is because then it becomes easy to calculate this number without counting it through, right? So I want you to be able to be like this. Hey guys, what's 8 times 4? And you're like 32. You're not like this. 8, 16, 24, 32. Is there anything wrong with doing that? No. But I want you to be able to calculate it relatively quickly. So if I tell you we're dealing with a pi over 4 kind of triangle and we're right here, this is literally the story that I say. Okay. I say, okay, well, a whole pie is going to have how many slices in it? And you're like, 4. Can everybody see why I say 4? 4 slices of pie? Yeah. But someone came and ate a piece of pie. Dun, dun, dun. How many slices of pie do we have? How many? And you guys are like, 3, Miss Johnson. Good. Out of what? 3 out of how many? 3 out of 4. Perfect. Oh no, don't do that. You erased. I thought you were on this. Okay. So this angle right here, this angle is actually called 3 pi over 4. Does everybody see that? Me going all the way around. Me opening the book up all like that is 3 pi over 4. Everybody good? Thanks for eating my pie. Just kidding. Okay. Everybody okay with that? So you can continue to choral count all the way around, but I kind of want to hit these last 2 green ones with my explanation again. Okay, everybody okay? Okay. So this next one, let me undo that pink one. Undo, 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 undo. Okay. So this next one, I have a whole pie. Everybody good? But we were at some kind of like function where there were lots of pies. So I have a full pie, and then I have some loner pie sitting by himself. Everybody see the loner pie? Good. How many slices do I have altogether? How many slices do I have altogether? Listen, I have a whole pie. I have a whole pie. How many slices is that? Mm-hmm. Very good. I have 4. And I don't know, pick your favorite pie. Strawberry pie, chocolate pie, apple pie apparently is one of your favorites. Pecan pie. Whatever pie is your favorite. It's a whole pie. Everybody see it? Like look at it. Good. And then I have some loner slice over here. How many slices of pie? How many slices of pie do you have all together? Very good. You have 5 slices of oops, too many sticks. How many slices of pie do you have? You have 5 slices of pie. Out of how many? Out of 4. Everybody follow me? If you can follow me on this, this is what my integrated 3 students are like. They're like, "Oh my gosh, Miss Johnson, I still don't get it." If you can get this now, do you see why like I'm prepping you for this next year? Because I don't want this to be your stumbling block. All right, let's continue. So this one right here is pretty interesting. So I'm going to go like this. I'm going to do that. Remember that this is or 2 pi. I have 2 pies, guys. Everybody see my 2 pies? Look, I have 2 pies. You guys can pick whatever favorite pie you want. Some of you are like pecan. Someone said the only right answer is apple. Okay. Very good. Now, how many slices do I have? How many slices do I have? How many slices altogether in my 2 pies? Good. I have 8 pi over 4. Good. 8 pi over 4. Okay. Yay. Look at my 8 slices of pie. Some of you are thinking, Miss Johnson, what is red pie? Strawberry pie. Hello. But one of you came and ate one of my slices of pie. Dang it. How many slices do you have now? It was you again. Dang it. Why would you do that to me? Okay, give me your answer. Very good. Someone said 7. Very good. Now write it with the pie in it with your denominator. Very good. I got 7 pi over 4, Miss Johnson. Everybody okay with this? So with this model that I like, this is literally the way it makes sense to me. When I was learning it, I was like, okay, this is how it makes sense to me. This is the way I'm learning it. And then since then, I've been teaching it like this, and it makes so much sense. When students count with me, when students think about pi, When they take away a piece of pie or add a slice of pie or whatever the case may be, it's done. The way you it with like actual pie. Yes, it actually does make more sense with pie. So this is us choral counting. And if you walk through, you can actually choral count all the way through. So I'm going to highlight so you guys can choral count with me. Pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4 is not pi. Oh, yeah. Yeah, it is, right? Because if you have a full pie and it's cut into 4, it's 4 pi over 4. Yes. Someone said, now every time I eat pie, I'm going to think of this lesson. Now you know why I did it, don't you? Just kidding. My goal is to have you guys think about me as many times. No, I'm just kidding. That's gross. Okay, let's go. 5 pi over 4. Miss Johnson, this isn't 6 pi over 4, but is it? Would these two be yeah, see? I know. Yeah, it's just simplified. Very good. Very good. Yes, I am a mastermind. Just kidding. Okay, continue. So 6 pi over 4, 7 pi over 4, 8 pi over 4. Did this never come through? 8 pi over 4. And you can continue all the way around like you were the little child that is spinning in that chair all the way around. Okay. Okay. I'm going to do something similar with these here. And I'm not going to actually build both of them. I'm going to build them together and you'll see why I do this. This is second to the last thing and then we are done. Okay. So again, this is 0. This is pi over 2. This is pi. This is 3 pi over 2. All right. So what we're doing here is we're going to choral count by pi over 6. And you will see that we're actually going to include our pi over 3 in there. And so that's why I'm doing pi over 6. Okay. When you're cutting a pie over here, you had like humongous pieces of pie, did you not? You took each pie and cut it into 4. Everyone was living the apple pie life, very excited. Huge pieces. Over here, we're a little bit cheaper with our pie. Maybe it's more expensive. I don't know why, but we're cutting these slices smaller. Maybe it's really, really sweet. How about that? So now we're going to cut our slices. Oh, it was Costco pie. But you know what? Costco's pizza is gigantic. And so they cut their pieces into these tiny little pieces, like just kind of cracks me up. All right. So instead of us slicing it into 4 pieces, we're slicing it into 6 pieces because of this denominator. Number of slices. Okay. So this is going to be equal to 6 pi over 6. Okay. So if you think about it, we're going to go by 30. So 30, 60, 90, right? And then same thing goes here. If these don't come out like super dang perfect, no, that was not perfect. That was irritating me. Hold on, let's try again. Don't worry about it. It doesn't have to come out perfecter. It just needs to kind of represent. That looks pretty good, I'm going to say. All right. So we are going to do the same thing that we did over here with our slices of pie, except over here, we're going to talk about pi over 6. So here's pi over 6. This would be 2 pi over 6. You guys are choral counting with me. This is 3 pi over 6. Does that really equal to pi over 2? It does, right? Oh, it's cheesecake. Okay, perfect. Cheesecake. Okay. So if I had cut my cheesecake into 6 slices, right? And I had 3 slices left, it means I have half the cheesecake left. I know. So someone said, I like how you incorporate food into almost every lesson. Is that horrible? Probably. Or maybe not. Baby pie. Oh my gosh. I didn't even see this. That's hilarious. Okay. All right. So let's keep going. So pi over 6, 2 pi over 6, 3 pi over 6. What comes next? Yeah, it does look like a firework. Yes, 4 pi over 6. Very good. Continue with me. What's next? 5 pi over 6. All right. Let's pause really quick. So I'm going to simplify first. This 2 pi over 6 actually equals to pi over 3. Oops, 3. Does that make sense? Right? And this 4 pi over 6 actually simplifies to 2 pi over 3. Okay. And I'm going to color these in a different one just so that you guys can kind of see these guys a little, like they stand out differently than the other guys. Okay. So it still works. Like, ignore. I wish I could take them away without ruining my drawing so much. Yeah, 6 pi over 6 is pi. Exactly. I'm also going to write 3 pi over 3. Right? Okay. So, can you all see? Now, I want you to pay attention to the yellow ones, right? Or actually, no. Let's do pi over 6. Can you all see this part here where I have cheesecake? I've got all my slices. I sliced them all up. Here's my piece. Here's your piece. Here's their piece, whatever. And then someone comes and eats a slice. Dun, dun, dun. Does everybody see how that has to be 5 pi over 6? Does everybody see that? Doesn't that make so much sense? Yeah. And doesn't, well, okay. Now thinking about that, can you guys find the one that would go right here? Can you write the one that goes right there? Very good. Awesome. Oh, no. My pencil came apart. All right. I got one person who knows it. What about you? I know you guys are writing it on your paper. So very good. Yes. Very good. Yes to you. Yes to you. All 4 of you. Perfect. 5 of you. Perfect. What? Did you find the sign? How did you find pi? What the heck? Whatever. You guys are fancy. I'm not. Someone figured out how to type pi in the chat, y'all. That is awesome. So yes, everybody who typed it, yes, it is 1 slice more than a whole pie. So the way my brain thinks is I go like this. I have a full cheesecake and it has 6 slices in it. Yeah. So think about your favorite cheesecake. What kind of cheesecake is that? I have no idea. Now you're all going to tell me about your favorite cheesecake, I'm sure. And then that's a full cheesecake, right? And then you have 1 extra random slice. So how many slices do you have altogether? 7 pi over 6. Everybody okay with that? Yeah, right? Okay, now that you figured out that one, you figure out this one too. Remember that this right here is 2 whole cheesecakes. It's 2 whole cheesecakes. So I said, how many slices do you have now? And someone goes, none, because I ate them all. You guys are too much. You guys have got math jokes with my cheesecake. Yes. Okay, we're focusing on 6, right? So this would be 12 pi over 6, right? 0 equals to 12 pi over, I mean, not equal to. I shouldn't put equal. Let me put like or kind of thing, right? So I have 12 slices and then one of you came and ate them. One of them, just one. Very good. 11 pi over 6. Very good. Everybody good on that? Okay. So when I count by pi over 3s, I've got to skip people. That's why I'm looking at the yellows. Does that make sense? So I go pi over 3. Let me see. I go here, pi over 3. I go 2 pi over 3, right? I go 3 pi over 3 right here. And then I get to this one here. So you could either skip count and tell me what there goes, or you can tell me. Now, these slices of, these slices are gigantic. They look like this, right? This is one slice right here. It's like big slices of, what is it called? Cheesecake. So how many would that be? How many would that be? Yeah. Okay, some of you are still counting with pi over 6. I love it. Some of you are not. That's even better. But yeah, this is 4 pi over 3. So the way that makes sense to me is I have a full cheesecake and it's 3 slices. Those are gigantic slices, right? Well, maybe it's a small cheesecake. I don't know. Okay. And then I have one random slice as well. So how much do I have altogether? I have 4 pi/3. So the last one that you're going to figure out for me is this one. And then we're pretty much done with our choral counting. Very good. Now here's what I don't expect. I don't expect you. Oh no. Yeah, 8 pi/6 is equal to 4 pi/3. Very good. Wait, check that one. Yes, very good. 5 pi/3. Very good. Last but not least, this is 5 pi/3. So if you paid attention to the ones with the denominator of 3, we got pi/3, 2 pi/3, 3 pi/3, 4 pi/3, 5 pi/3, 6 pi/3, right? Okay. So this right here and this right here just built us this right here. Okay. You just did pi/6, 5 pi/6, 7 pi/6, 11 pi/6. Do you guys all see the ones that you guys did? Yeah. Now, some of you are thinking, Miss Johnson, I get that, but where did they get this? And that's the last thing I'm going to explain, and then we're going to call it a day. So this is based on, and then, by the way, the only thing new that I taught you was this up here. That's it. The rest of this stuff here is you just using that. So don't think, oh my gosh, we learned so much. No, you're just using it in a different way. The next thing that I'm going to teach you has to do with your SOHCAHTOA, which is not new. Do you guys remember SOHCAHTOA? Okay, in case you don't remember SOHCAHTOA, it means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's that and the idea of doing one of those. So I'm going to pull one of these angles here and explain why it's √3/2. Okay. So let's say that your teacher says, hey, I want you to find the sine of 30 degrees. So then you're like, okay, Miss Johnson said to draw the angle, draw the triangle by taking the elevator to the x-axis. So you take it to the x-axis here, right? And then labeling your triangle. Because this is your 30, this is 1 to √3, right? So far, so good? Okay, very good. Actually, I don't know if you guys know this, but this, by the time you guys get to this, there's so many things that the teacher will pack in. There's so many things that I had to pack in as a teacher that it was a lot confusing. Okay, so here, the way they came up with these numbers here, these coordinates over here, has to do with two things. Has to do with sine and cosine and the definition when you're in the unit circle. The reason why this is called the unit circle is because it's a circle whose radius is 1. Okay. So last but not least, and some of you are thinking, but Miss Johnson, your hypotenuse is 2. I understand, but I'm building this off of what you know. Okay. So the last thing that I'll teach you, and this is something new, is in the unit circle, x equals to cosine of theta and y equals to the sine of theta. So if I wanted to know what this coordinate is for 60 degree or for 30 degrees, I just have to find the cosine and put it in the x and find the sine and put it in for the y. So we're not going to practice this one because I want to show you one more. If I said, hey, you guys, can you graph for me 5 pi/4? Where's 5 pi/4? So go ahead and put your best guess on 5 pi/4. And you're like, okay, Miss Johnson, this is like pizza. I have a whole pizza, Miss Johnson. You're right. And then you have an extra slice, don't you? You're like, yeah. So he goes here. How many people got that? Yeah. Okay. So the next thing that I do is I recognize that because this is a denominator of 4, that means I'm in my 45, 45, 90 triangle. That means this is 1, 1, root 2. So the last thing that I'll share is this. When you go left, what does that mean? When I go left, what do I have to remember when I go left? Yeah, it's negative. Very good. Right? What happens when you go down? You go down. Yeah, it's negative. Does that make sense? So when I ask you for, say, like here, the cosine of 5 pi over 4, I know it feels weird because you're like, okay, well, how do I draw a triangle as big as 5 pi over 4, Miss Johnson? You don't. You actually just use this reference triangle right here. So because cosine is adjacent over hypotenuse, that's your answer. Does that make sense? Okay. This last little part here is probably the most challenging part. So I'm going to give you one more practice problem, and then I want you to take the time to look at it. So I want you to find the sine of 11 pi over 6. So your first task, draw the angle. Draw the triangle. Label your triangle. And then SOHCAHTOA it. That's not a word. All right, we'll be back to check your answers. Go ahead and pause. All right, here we go. All right, so a lot of you figured out as much as you could, and now you're a little stuck. So I'm going to unstuck you. So 11 pi over 6, a lot of you said, well, Miss Johnson, 6 pi over 6 would be here. 12 pi over 6 would be here. And then someone stole a piece of your pie, right, Miss Johnson? Exactly. Go find them. Okay. So you also figured out this was a 30, 60, 90, which you needed to know. Okay. So this is your 30 degrees here. So if you got, I'm going to pretend that this was a quiz. And if you got this far, this is like half of the point. So give yourself 5 points if you got this far. The next part is you labeling your triangle. So because this is a 30, 60, 90 triangle, the side that's opposite of 30 is your one side. Okay. And then this is 2 because your hypotenuse is always 2. And then this is root 3. Then check your signs. To get to this point right here, you went right. Is right positive or negative? Yeah, good. It's positive. Very good. When you go down, is that positive or negative? Very good. It's negative. So this one, he needs to be negative. So if you remember back in like 7th grade or maybe 8th grade, when your teacher taught you the Pythagorean theorem, they're like, yeah, and the side of a triangle can never be negative, right? Please don't think that these are now negative. It's not negative. That's not a negative side length. It's just a negative direction, right? We talked about this before. Like if if counterclockwise is positive, that means clockwise is negative. It's not negative because it's negative. It's negative because it's sorry, someone said to zoom out. It's negative because it's going in the opposite direction. So we were talking about direction here, right? Okay, very good. So sine is opposite over hypotenuse. So that means it's 2. That's my hypotenuse. Sorry. My opposite side is -1. So this is -1/2. So if you got all of that, that would be 10 points total. But most of the points were you just graphing the triangle, period. Does that make sense? If this makes sense, then when you learn this next year, they're gonna layer other things on top of it. But I want you going in strong into your next math class. Does that make sense? Because that's my job. My job is to make sure that you are succeeding not this year, but this year and beyond. Yeah. All right. So again, I'm going to go over a couple things as a reminder. So we first started this conversation about radians. Radians is like how we can measure an angle. Remember, we use the analogy of a book being closed, sitting on the table. That's where 0 degrees is. And as we open the book up, right, it is opening up positive in the counterclockwise direction. Then we started talking about our 30, 60, 90 triangle, which, if you don't remember it, I would definitely put this somewhere. When you start going over this section next year, put it, I would, the way I did, made my students do homework in person was these two triangles had to show up on every single homework until they understood it at the top so they can constantly reference it. Like when they're doing problem 10, oh no, I don't remember my 30, 60, 90. Not a big deal. Reference up at the top of your paper. We're good. Yes, it will be on our final. Okay. Then we did choral counting, which this is the piece that you guys really liked, right? We talked about whole pies, whole cheesecakes, whole pizzas, taking away a slice, adding a slice, and how that math all works together. And then the last little piece that we did is we put basically all of this together into the questions that you actually see next year, which is I need you to find me the sine of 11 pi over 6. So the very first thing you're going to do is graph the angle, graph the triangle, and label your sides. And then it's just a matter of you going SOHCAHTOA, which is what you learned this year, and do that. So all in all, the things that let's see, you are not responsible for the final because it's really in the next year's math class, would be this stuff over here. Does that make sense? But I want you to see this because a lot of you said, oh my gosh, when I showed you our notes from integrated 3 and the other class, a lot of you were like, oh, I can't do that. You just did. So you're welcome. All right. So hopefully that makes sense. Thank you for listening.